it is usually a little bit more challenging for people to add and subtract fractions than to multiply and divide fractions. Because to add and subtract fractions, you have to have a common denominator. You don't have to have a common denominator to multiply and divide, only to add and subtract. And unfortunately, a lot of us don't remember our fractions. And so, do you see that this example number 1 has a common denominator? So the answer will have a common denominator. The same common denominator is in the answer, and to add fractions, you find a common denominator first, and then you add the numerators. And so this is the answer when you add the numerators. Example number 2 already has a common denominator. The answer is going to have the same common denominator, and you add up the numerators. Now, when you do this right here, does this have any adding glue? No adding glue, and so this 3 divides into 6, and you always have to simplify the answer. But in the next part, before I get to the next part, let's think about, do you remember just regular old numbers? What would be the common denominator here? 12 is the least common denominator. By the way, 24 would also be a common denominator. You can always get a common denominator by multiplying the denominators, but it's easier if you can figure out what the least common denominator is. Okay, now that we've figured that out, we've got to change this so that it has a common denominator of 12. I do that by multiplying by 1. If I multiply by 1, does that change the value? No. Well, how does that do any good then? That is equal to 1. Does it change the value? Doesn't change the value. Doesn't change how much I have. But it changes what it looks like. Remember, you multiply numerator times numerator, denominator times denominator. I would multiply this by 1 in this form so that they would have a common denominator, and then you add the numerators. That is what whole numbers are equal to. And so yesterday we got these notes ready by already finding the factoring. And now we're going to use the factoring to find the common denominator. What does denominator mean? You can't use denominator to define denominator. It's the bottom part of the fraction. So if we're going to call those denominators, they have to be part of a fraction. I'm sorry. So, in order, back over here on my numbers, would you agree that my common denominator has to be equal to or bigger than 4? I can't have a denominator that's less. My common denominator can't be less. Can't be smaller. It's got to be at least that big or bigger. That's the same thing over here. My common denominator is going to start with my first denominator. It's going to have all of those. Now, does it already have an x minus 3 up there? Or yours is side by side. And so I don't need another one. Do I already have an x minus 2? No. So my common denominator is going to be x plus 3, x minus 3, x minus 2. It's going to have this term in it and this term in it. It already had that one, and then it also needs that one. It's got everything covered in there. Example 4. Again, yesterday we already factored it out, so we would be ready to find my common denominator today. You start with the first denominator. It's got to have at least that much. Then, does it already have a 2? I don't need another one. Does it have a 3? Does it have an x? Just an x by itself, not added to anything? Does it have an x, so I need one of those? Does it already have an x plus 2? So I don't need another one. That is what my common denominator would be. Let's take that idea of common denominator and apply it to an adding problem. When I add on problem number 5, I have to find a common denominator first. Now, this one, nothing factored out of that, so it doesn't have any common factors. So you can see my common denominator is all the way down here at the bottom of my paper. You need to put the common denominator all the way down at the bottom of box number 5, because that's going to be the denominator for my answer. This is the denominator on the answer. If they don't have any common terms, you just use both of them. You can always find a common denominator by multiplying the two denominators together. Now, what do we do from there? This is the first fraction. This is the common denominator. What does this denominator have that this denominator does not have? This one has an x minus 1. This one has an x minus 1. This one has a 2x plus 1. This one doesn't have a 2x plus 1. And please use your red pen to put in the 2x plus 1. Because you are multiplying by 1, you have to have these on the top and bottom, so you change the form without changing the value. Here's my second fraction. This has an x minus 1. This doesn't have an x minus 1. And if you will use the red pen, it just helps it show up so you can see it better. Now, I'm going to put this across here to show that I am working on the next step. Do you see that they both have the same common denominator now? They're not in the same order, but they're the same factors. That is the common denominator, so I'm going to put my numerator over the same common denominator. That needs to get multiplied together. By the way, it helps it show up if you only use the red pen for these common denominator multipliers. 2 times 2 is 4x. 2 times 1 is 2. 3 times x is 3x. 3 times 1 . Next step. The next step is to combine like terms. 4 and 3 would make 7x, 2, and that would be -1. Nothing else will reduce. There's your answer. On problem number 6, yesterday we already found the factors, and so we already factored out the denominator. Down here, all the way at the bottom, I have my common denominator. My common denominator starts with the first denominator. Do I already have an x plus 3, x plus 2 in this part right here. So I need a x plus 2. Do I already have an x minus 2? I already have it, so I don't need another one. That is my common denominator. This is in there in both terms. I don't need to repeat it because it's already in here once. Now that I have my common denominator, then I need to find my new numerator. I have a 3, x minus 3, x minus 2. What does this denominator have that that denominator is missing? What does this denominator have that that denominator is missing? So now I need to combine those over my same common denominator. Both of these have this denominator. I need to multiply, I need to distribute 3x plus 6. And I need to distribute 2x minus 6. And then for my last step, I need to combine like terms. 3x plus 2x makes 5x. And what's going to happen to my 6's? This positive 6 is going to cancel out that negative 6. So this is my final answer. Unless, can I cancel an x up here and an x down there?
No.
Because these have adding and subtracting glue. Can you find the common denominator for the next problem? Oh, this one's kind of tricky. Here is the first denominator. Do we have an x minus 5? Do we have two x minus 5s? Have it just that much. If you don't have this last term on here, do you have two x minus 5s? That's why I said this one's the hardest one to see. Maybe I can explain it this way. This part down here circled in the yellow is the first denominator. You see the first denominator? This part right here is the second denominator. You've got to have all of both of them. This has two x minus 5s, so this has to have two x minus 5s. This is repeated. Another way that I explained it, that helped some people understand, that represents this term and that term. That's the repeated term. We also need one of these and one of those. Is that enough arrows to help you figure it out? Okay. So, what do I need in this denominator to make it equal to that denominator? I need another x minus 5. What do I need in this denominator to make it equal to the one on the bottom? Now I need to calculate the new numerator. This is easy. 1 times x minus 5 is x minus 5. Plus 5x, multiply that, you get 20, all over the common denominator. Next step, combine like terms. That's going to give me 6x minus 25. Does anything factor or cancel out here in my final answer? You always have to check your final answer and make sure it cannot be reduced any farther. Do I need to multiply this first fraction by anything for this denominator to equal that denominator? It's already equal, so this one doesn't get multiplied by anything. This term right here, what am I going to need to multiply so this denominator equals to that denominator? Please make sure you put the parentheses in there, because the parentheses shows me that this binomial multiplies by that binomial. I have to multiply binomials here. I guess I need to put in the next step. And so my denominator is x plus 3, x minus 3, and this is 8x plus this multiplied together. To multiply this together, I'm going to probably need to get out my scratch paper. And as you know, I prefer to multiply binomials with a box problem. You can use FOIL if you want to. So this is going to be, well, first, this is what it's going to be. I multiplied the binomial times a binomial using a box problem. Now, why did I have to use a box problem here on this problem right here? This is a binomial times a binomial. In the previous problems, we just had a distributive. This is a double distributive, and so this is going to be x squared minus something. Yes, I was just noticing right here that I wrote this down with the wrong sign. This has an x minus 3, and I need an x plus 3 so that my denominators match, because this is supposed to be a plus 3x minus 21. And so when you multiply it out, actually, on the scratch paper, I wrote it down correctly. And so here I need to combine like terms. So I have an x squared, that's going to be 1, plus 4x minus 21. Now, don't circle that as your answer, because this will factor. So I go back over here to my scratch paper, x squared plus 4x minus 21. That adds up to negative 4. This factors into that's why scratch paper is handy. So back over here on this problem, this factors into x minus 3x plus 7, x plus 3, x minus 3, and then what happens? And the final answer is x plus 7, x plus 3. Now, why did this have more steps than the previous problem? This numerator right here would factor. And so it would factor and cancel out part of the denominator. And so on this previous problem, would that factor anymore or cancel any of the denominator? That's why this problem number 8 had more steps, because this would factor. When you factored it, it would cancel, and you need to simplify your answer as much as possible.